We need to evaluate the definite integral from 2 to 4 of x minus 3, all divided by the square root of 5 minus x times x minus 1. This is a Tier 2 integration problem where we'll use algebraic manipulation and substitution. Let's first analyze the expression under the square root. Expanding the product, we get negative x squared plus 6x minus 5. This quadratic expression suggests we can complete the square to simplify it. Completing the square for negative x squared plus 6x minus 5 gives us 4 minus the quantity x minus 3 squared. Substituting this back into the integral, we have the integral from 2 to 4 of x minus 3, divided by the square root of 4 minus the quantity x minus 3 squared. Now let's use a substitution to simplify further. Let u equal x minus 3. Then the differential du is equal to dx. Since this is a definite integral, we must change the limits of integration to match our new variable u. When x is 2, u is 2 minus 3, which is negative 1. When x is 4, u is 4 minus 3, which is 1. The integral now becomes the integral from negative 1 to 1 of u divided by the square root of 4 minus u squared, with respect to u. Let's examine the function we need to integrate in terms of u. Our integrand is the function f of u, which is u divided by the square root of 4 minus u squared. To check for symmetry, we'll evaluate f of negative u. We evaluate the function at negative u. Substituting negative u, we get negative u divided by the square root of 4 minus negative u squared. This result is negative u over the square root of 4 minus u squared. This is exactly negative f of u, meaning our function is odd. So f of u is an odd function. The integral of an odd function over a symmetric interval from negative to positive is always 0. Since our interval is from negative 1 to 1 and our integrand is odd, the integral is 0. Let's quickly verify this result by performing the integration explicitly. To verify, we find the antiderivative of u over the square root of 4 minus u squared. This antiderivative is negative the square root of 4 minus u squared. Now we evaluate this antiderivative at our limits, from negative 1 to 1. This is negative square root of 4 minus 1 squared, minus negative square root of 4 minus negative 1 squared. This simplifies to negative the square root of 3, minus negative the square root of 3, which equals 0. Our verification confirms the result. The value of the definite integral is 0.